Hi all, welcome to part 6 of the video lecture on registers. So we are seeing different types of registers, right? So register is one which can store information and also you can do that shifting if needed. So shift itself, we have different ways of shifting towards right, towards left, and shift and rotate, like that combinations we are having. And again, how we are feeding input and output in a serial manner or parallel manner. Accordingly, we have four types of register, like serial in, serial out, serial in, parallel out. These things we saw already. Now we are going to see the third category, and parallel in, parallel out is the fourth one, that also we see. Third category, that is parallel in and serial output shift register. So it's very easy, right? So input you have to give simultaneously in a parallel manner to all the flip flops, but output you should take in a serial manner only. So what was the challenge in that? Let's see. For a register with a parallel data input, the bits are entered simultaneously. So that is our requirement. So accordingly, that many input lines will be there into the respective stages of flip flop on parallel line, rather than on a bit by bit fashion. So in serial in, bit by bit we will enter the data. So here we don't want it. We want to apply all the input lines simultaneously to this flip flops. So the serial output is the same as in output should be taken just like in PISO, serial in, serial out. That serial out manner you can take. So to take the output in a serial manner, you have to shift each bit so that they will come at the last flip flop, and like that you can take one after another. But you should do it only after completely loading the data into the register. So this is the idea. So here I tried to draw this diagram, and I just want to ask you how it can be achieved, right? So the first thing is you have to enter the data in a parallel way. So one way you can think about of it is you are taking the data in a parallel way. So like this. So this is your. So everything you have to apply simultaneously, like input to 0, input to 1, input to 2, input to 3. So in any order, MSB to LSB or something. Accordingly, you will get the output. So if you are giving like this, the MSB bit you will get first. If you are applying I0, then I1, I2, I3, then you will get the least. So this is always preferred, least significant bit. Okay, anyway, how you are reading, that is immaterial actually. Okay, somehow the input bits are applied to the register, and after that, so that loading is over now, right? The input is loading. Now the problem is we don't want to stop it after loading, right? If you want to take the data as a output, you can take like this. That is fine. But here we don't want to take the data in a parallel manner. Instead, we want to take the output in a serial manner. Like to take the data in a serial manner, this should be connected to this. Now how it is possible? Two inputs are coming, right? Is it easy for us to, so then only this shifting will happen and finally data will come out like this. So this connection like that. Now two inputs are coming, the actual input as well as the output of the previous flip flop. So which you will apply actually to this T, because this flip flop can accept only a single bit, right? So out of the two, one should be selected depending on whether you want to load the data or you want to shift the data. Accordingly, one thing should be selected, and that should be given as input to the D flip flops. Okay, so to achieve that, you have to select one out of two. So you can implement it in a number of ways. So the simplest way is to use a 2x1 multiplexer. Okay, so based on the select line, it will select either of the inputs. I mean the actual input or the output of the previous flip flop as input to the current one. So that will happen. So using multiplexer, and that multiplexer itself we can implement using normal AND gate and OR gate. So anything you can use. Okay, so a multiplexer is something easy to visualize. That's why. Anyway, what about the select line of the multiplexer? When you want to load the data, or when you want to shift the data, so that you have to decide, right? So some control input will be there for the multiplexers. So that is something like a load bar shift, like that we denote, and typically shift we will use a bar, meaning that whenever this line is having a 0, the shift operation will be activated. Whenever the line is having a value of 1, load will be executed. Okay, so you can give the input in different way also. So this is a default assumption that is given in textbook and all mostly. Okay, so that will be the select line of the multiplexer, and accordingly it will select the actual input for loading, or it will select the previous output for shifting. Okay, so let's see that. Let me erase this is how I was trying to draw the circuit, and then I understood the correct way. So you should also do so when exam, when a new question is coming, you should by trial and error method, you should try it first, then automatically that idea will come how to implement it actually. Okay, so that is what I also tried here. Now let's see how we can achieve it, right? So with the help of this the first input, oh sorry, that line I was trying to erase. Anyway, 4 flip-flops we are having. Now what I am going to do is I am going to apply that multiplexer like what I said you. So you know the typical structure of multiplexer. So for the multiplexer, there will be one output, and that output I am feeding as input to the D flip-flop. So this is my D, and there will be 2 inputs, okay. And what is the first input? So this is input to 0 and this is input to 1. So the input to 0 will be selected when that control line is having a value 0, otherwise 1 will be selected. So what I am trying to do is this for the input to 1, I am applying the actual input bit, say more significant bit. Then there will be another multiplexer used here, here also. Its output I am giving to this D flip-flop. Now here also 2 inputs will be coming. Let's see that second input bit, sorry, not I3, then the next bit will be I2, right? I2. Similarly I am using a multiplexer here also, output of which I am connecting to this particular D. Okay, now 2 inputs are coming, say I3, and this will be a I1, okay. And here also I am having a D. This is the last bit, okay. Anyway, now this is how I filled 0 1. 2 inputs are there, the one of the input, I mean the input 1 I filled like this, I mean here I want to load the actual data. Now what about the other input? And that input will be, see, this is a tricky part here. Now tricky, like this is where the shifting is happening, okay. So the output of each flip-flop I am giving as input to this, and this output I will be applying here like this. Now what about this one? This is a I mean here the shift will happen, and you know during that shift we are doing this right shift to get the data out, right? So and that time the more significant bit you will it will be lost, right? And that time you can fill that space with a 0. If it is rotation and all, you can take this last output and you can give us input to here, then it will do like a clockwise rotation, okay, fine. Okay, but here we just need a shifting only, that is why we are setting it to 0, okay. Anyway, that is the thing. Now what is missing here? So this is your output, like the parallel in and serial out. Yeah, let me write like Q3, Q2, Q1 and Q0. So always you will get the least significant bit first, then the next bit, like that you can take the serial out. So let me write it like serial out. Serially I am taking the output. Don't confuse that word. So what I mean is serial output. Okay, fine. Anyway, which is missing here? Multiplexer, there should be a select line. So I want to draw that also. So what I am doing is, see, I am having a select line and this is my select line, okay. And from this select line, so here there is a space deficiency. This is connected to the select line. So this is a select input, say. Similarly, this is connected to select input of this multiplexer, and this is all again connected to the select input of this multiplexer, and here also the select input of this particular multiplexer. So like that I am connecting. This is the select input, say. So now what is the value I should give here? This is my load bar shift control line. So what is meant by this notation? So what does it mean? Load bar, I mean load or shift bar, like that. So the meaning is, so this is single line, right? So if this line is equal to 1, it will perform what? Load operation, I mean the parallel load operation, right? Now when this one is equal to 0, I mean, so that 0 means load will not be activated, so 0 bar, that will be 1. So that this is shift is active low, right? So it will perform the shift operation. What kind of shift? You want to take the data out, right? So the right shift operation. Okay, so this what is your this I3, I2, I1, I0 is your parallel input. Okay, that also you can mark this I3, I2, I1, I0. These are all your parallel input bits. So that about the diagram. Hope you get an idea about it. So what I done is just I used a multiplexer in addition to the normal flip-flop. Why I used like that? Because I should have a clarity like when to load that parallel data and also when to shift, because it is doing both, right? In this serial in and parallel out, it is fine, because after doing that shift, just take the data out, that is okay. But here that loading will come before taking data out. So so there should be a control line, right? So, and that control line is equal to 1 will load the data into the flip-flops, I mean into the register, or store the data into the register, and when it is equal to 0, it will do that shifting operation. Okay, one after another. So it is just like maybe it, for whole thing it may use 5 cycles. So for during the first cycle, you can make a load bar, load or shift bar, that particular line as 1, so that it will load all the input. Now shift you have to enable, and again to shift out all the 4 bits out from the register, you have to apply 4 more clock cycles. So totally there will be 5 clock cycle for on time data load and reading it in a serial manner. But that is not fixed. You can in between at any point you can stop also, right? So hope you get an idea about how this serial in parallel out shift registers are working. Not serial in, it is parallel in serial out shift register. Okay, so this is a typical logical symbol. Again, by symbol it's very clear, right? It's understood. So what we added extra is this shift or load bar. Okay, sorry, it's here it is written like so what does it, this anyway, this notation is now clear too, right? You can write it in this way or that way, anyway it is fine. So here this one, oh, why it is so? Because they are already made this as active low. So the same working will be happening, but as the input is active low, low value will activate it. I mean here it is slightly confusing actually, but I hope it is clear, because similar thing we already seen, right? Different variations. So whenever this shift is 0, this one will be activated, means 0 value for this will do that shifting operation for you. Sorry for that, because yeah, on the background that this diagram only, so this diagram is simply denoted like this. Okay, so don't think much about it, because okay, that depends, you can implement this way or that way, all are fine. Okay, so there is a control line, shift bar, load bar. Here what I taken like load bar, shift bar. Okay, so whatever it is, both are same only, but slightly different variation. So that here this, whenever this shift is equal to 1, this will be activated, I mean shifting will happen. So it's giving some kind of highlight to shift operation. Whenever that load is equal to 1, so that load bar will be 0. So 1 second, let me so slightly confusing, yeah, and actually nothing, let me write it here. It's something like a shift bar, load bar, like that it is written. And it is an active low input also. So what does it mean? Whenever this line is equal to 1, what will happen? Line, that line, single line, it is having a 1, so that its negation will be 0. That operation will happen. Okay, so its negation is actually applied as, this is actually our select line, right? So select line will select what? So the maybe it's the shift operation will, and that also depends on how you are applying the input. Okay, so here what I mean is that shifting I want to apply there. Okay, the shift operation. Similarly, whenever this is equal to 0, so that load bar is equal to 1, so this will do that load operation. So this is what we need from this kind of a notation. So if you are because it is taking negation 2 times, so it may be slightly confusing, but anyway now it is clear, right? Anyway, in for exam you can write this. So this is something easy to understand. Load is equal to 1 will load that operation, because we are connecting it like select line of the multiplexer. Same thing you have to do other side also. and whenever that this is equal to 0. So okay, this is one way of applying control line. Here they are applying it as active row, just opposite. So here this control line is equal to 1 will do the shift operation and 0 will do the load operation. Fine. So that about it, and input is coming in or inserted into the flip-flop register made out of flip-flops in a parallel manner, and we are trying to take the data out from the flip-flop in a serial manner, and that is by means of successive shift operations, so that one by one bit you will get. Okay, but whenever the input is over, you can immediately enter the data parallelly and then then you can shift like that. So this notation itself says that it is for parallel in and serial out register. Okay, fine. Thanks for watching.